Good afternoon. Today I start relations. Let A and B are two non-empty set. Set a relation set a relation R from set A to set B is subset of A cross B, that is R is subset of A cross B. The subset, pay your attention on this word which I am going to write. The subset is derived by describing a relation between first element A to a second element B of the ordered pair AB in A cross B. You remember the sentence? The subset is derived by describing a relation between first element A to a second element B of the ordered pair AB in A cross B. A relation R from set A to B is a subset of A cross B. The subset, this subset is derived. This is not an ordinary subset. This subset is derived by describing the relationship between the element of A and B, like this. For example, mother and son. What relationship in this ordered pair? Mother and son. She is mother of that. Husband and wife, teacher and student. Like that. The subset is derived by describing a relation between first element A to the second element B of the ordered pair AB in A cross B. Now, note, you remember these lines because these lines are used to solve the question. If AB belongs to R, implies A related to B. Second, if AB does not belong to R, implies A is not related to B. Third, if R equals to 5, then this relation is known as empty relation. Fourth, if R equals to A cross B, if R is same as A cross B, then this relation is known as universal relation. Fifth point, if R1, R2 are relation from set A to set B, then R1 union R2, R1 union R2, R1 intersection R2 and R1 minus R2 are also relation from set A to set B. These points are very important in the reference of relations. Now you know I am talking about another things. By that method we can show the relationship arrow diagram if I make an arrow diagram is given between two non-empty set then it is a pictorial diagram of relation and pictorial diagram is the visual representation of relation. Visual representation of the relation. You remember this point. An arrow diagram is given like this. If I define a relation R as an ordered pair AB such that B equals to A plus 1 and A assumes the value 0, 1, 2, 3. So in this case, if A is 0, B is 1, if A is 1, B is 2, if A is 2, B is 3, A is 3, then B is 4. When you take your set A as 0, 1, 2, 3, 0, 1, 2, 3 and set B as 1, 2, 3, 4. In this way, When you take two sets A and B, this is A, this is B, 0, 1, 2, 3, 1, 2, 3, 4. 0 is related to 1, 1 is related to 2 under this relation, 2 is related to 3, 3 is related to 4. So this is called the pictorial representation. This is by arrow diagram is pictorial representation of the relation, and pictorial representation is also the visual representation of the relation. You remember this point, it is very important. Sometimes it is used in competitive exams also. So now you see another things. Question after this, question. I am taking question. Now I see that. I want to explain the relation by example. In this question, I am taking the same type of things and you can go through it, and with this example, with the help of this example, you try to understand the relationship between two sets. Question. Let set A equals to 1, 3, 5, 7. Set B equal to 6, 8, 10. If R is a relation, if R is a relation from set A to set B, defined by less than. Now you remember that this is the relationship between the first element by describing the relationship. Now I am describing the relationship between the first element and second element of the set. Let R be a relation from set A to B defined by less than. Your first element is less than the second element. This is the relationship. Less than, find R. Also draw its pictorial diagram. Also draw its pictorial diagram. That is the question. First you find the relation and then you draw the pictorial diagram of that relation. Visual representation of same thing. Arrow diagram, pictorial diagram, visual representation, same thing. It can be asked with different names and they have the same meaning. So now you see, first in order to find the elements of relation, you find A cross B. First of all, you find A cross B. A cross B equals to set A 1, 3, 5, 7 cross 6, 8, 10. Now you see your elements of A cross B are as follows: 1, 6, 1, 8, 1, 10, 3, 6, 3, 8, 3, 10, 5, 6, 5, 8, 5, 10, 7, 6, 7, 8 and 7, 10. These are the elements of A cross B. These are the element of A cross B. Your relationship between the numbers is less than. That is the relationship between the first element and second element of each ordered pair. You test that. In first ordered pair, 1 is less than 6. So 1 is related to 6. 1, 6 is a member of that relation. 1, 8, 1 is less than 8. 1 related to 8. And 1, 8 is the member of that relation. So among all the elements of A cross B, there is only one element in which first element is not less than the second. That relationship is not satisfied in this ordered pair only. So that is only not the element of your relation. So first of all you write 1 related to 6, 1 related to 8, 1 related to 10, 3 related to 6, 3 related to 8 and 3 related to 10, 5 related to 6, 5 related to 7 and 5 related to 10, 7 related to 8 and 7 related to 10. So in this way you can write the elements of your relation as 1 6, 1 8, 1 10, 3 6, 3 8, 3 10, 5 6, 5 7, 5 10, 7 8 and 7 10. These are the elements of a relation. Your question was find R. So you have find your R. In this way, by listing the element of your relation, you have obtained the set, the relation R. And now you have to show this relation by pictorial diagram. Pictorial diagram, visual representation and arrow diagram all are the same things, but it has different name. So this is your set A and this is your set B. In set A there are elements 1, 3, 5, 7 and set B 6, 8, 10. 6, 8, 10. This is your set B, this is your set A. You are defining the relation from set A to B. You have to show this relation by pictorial diagram. So 1 is related to 6. You join 1 and 6 by a straight line. And 1 is related to 6, you make it arrow on this. This so that 1 is related to 6. And 1 is related to 8. You join 1 and 8, you make an arrow on it. 1 is related to 10, you put an arrow on this. 5 is related to 6. 5 is related to 6. 5 is related to 8. And 5 is related to 10. 7 is not related to 6. So 7 is related to 8. You put arrow here. 7 is related to 10. Put arrow here. So now this is the pictorial diagram for this relation. You have shown here for this question. Now another question. Question: if set A equals to 1, 2, 3, 4, set B equals to 5, 6, 7, 8, then which of the following are relation? Then find which of the following are relation from set A to set B, from A to B. Give reasons for your answer. Why this is relation? Give reason for your answer why that is a relation. Note this part. Give reason for your answer. And one more question in it. Also draw pictorial diagram. Also draw its pictorial diagram. That is the question. Set A and set B are given and your relation are defined as first relation is R1 equals to ordered pair 1 5 2 7 3 8 and second relation is R2 6 2 3 7 4 7. Now you have to find out, first part of this question is you have to find out which one is the relation and why. You have to give reason also. And another, if you have shown that, you show that relation by pictorial diagram. Means you show its visual representation. So now you see. In support of this question, first of all, you need to write the Cartesian product of given set. And the definition to be a relation from set A to set B is your R is subset of A cross B. You have to show that condition. So first of all, you write A cross B. A cross B, that is equals to set 1 2 3 4 cross B is 5 6 7 8. Now you see your elements of A cross B are 1 5, you write element of A cross B. 2 5, 2 6, 2 7, 2 8 and 3 5, 3 6, 3 7, 3 8. Then 4 5, 4 6, 4 7 and 4 8. So in this way you have written A cross B. A cross B has 16 elements because 4 elements in A and 4 elements in B. The number of elements in A cross B is 16. You may count that. Now you see your R1 is, I am now we are going to check for R1 whether this R1 is a relation from A to B or not. So I am doing that things for R1. R1 is equals to 1 5, 2 7 and 3 8. You observe that 1 5 is an element of R1, 1 5 is element of A cross B. 2 7 is element of R1, 2 7 is also element of A cross B. 3 8 is element of R1 and 3 8 is also element of A cross B. This means that every element of R1 is an element of A cross B, and that is the definition of subset. Here, since every element of R1 is an element of A cross B. So that is the definition of subset. So in this way, R1 is subset of A cross B. Therefore, R1 is a relation. R1 is a relation from A to B. What about R2? 6 2 is element of R2, but 6 2 is not element of A cross B. Six 2 belongs to R2, but 6 2 does not belongs to A cross B. Therefore, R2 is not subset of A cross B, and R2 therefore R2 is not a relation. Therefore, R2 is not a relation. This is not relation from A to B. So, there is no requirement for R2 to show it by pictorial diagram. You show R1 by pictorial diagram. R1 has, I am showing R1. This is the figure for R1. While showing the relation R1 from set A to B, you have to choose set A and B, not the element of R1 and R2. If there is the question, find the domain and range of the relation. I will talk to you later on, because this is after some question. When you understand some question, then you can understand what is the domain of relation and what is the range of relation. How can you find the codomain? All that there will be. So I will discuss it later. So I am going to define this relation R1 from set A to set B. So we need to write all the elements of set A and set B. So element of this is 1, 2, 3, 4, and element of B is 5, 6, 7, 8, and here in R1, 1 is related to 5. Make care of that. Now 2 is related to 7. 2 is related to 7, and 3 is related to 8. So this is the pictorial diagram for R1. This is the relation R1 from set A to set B. Now, need to find the number of relations from set A. Now, my objective is to find the number of relations from set A to set B. If number of element in A is equals to m, number of element in B is equals to n, then number of element in A cross B, according to the formula, this is mn. Now I am going to find out the number of subsets. Number of subsets of A cross B. How many subsets are there? If A cross B has mn element, then there is 2 to the power mn subsets. Number of subsets is 2 to the power, there is 2 to the power mn subsets, and subset of A cross B is the relation from set A to B. Subsets of A cross B is the relation, you know this fact. Subsets of A cross B is the relation from A to B. Subsets of A cross B is the relation from A to B. Means total number of relations is equal to total number of subsets. Number of subsets. This implies that this is equal to 2 to the power mn. There are 2 to the power mn relation if set A has m element and set B has n element. So this is the total number of subsets and this is the total number of relations. Now question based on that. Question. Let set A is xyz. It has 3 elements xyz, and set B is equal to 1 3. Find the number of relations from set A to set B. Find number of relations. Number of relations from set A to set B. That is the question. Number of element in, first to find the number of element in A cross B. Number of element in A multiply by number of element in B. That is equal to 3 into 2, 6. Number of element in A cross B is equal to 6. So by this formula, number of relations equals to 2 to the power mn, that is equals to 2 to the power 6, that is equal to 64. There are 64 relations from set A to set B. Now domain and range of, now I am going to define domain and range of a relation. Now I am going to define the domain and range of a relation and distinguish between the range and the codomain. A relation R is defined as an ordered pair AB such that AB belongs to R. If this ordered pair AB is an element of R, then the elements of this relation R is the ordered pair this. This is ordered pair because this is written in a specific order. Their relationship is fixed. So R is defined as A cross. How can we define the domain of this relation? Now, domain of this relation is defined. Sometimes this definition is straightway or asked in the competitive exam. Domain of this relation. This is defined as a collection of first element A. This is a collection of first element A such that AB is member of R. You collect the first element of each ordered pair and that will form the domain of this relation. And now range of the relation. Range of this relation is equals to, this is defined as the collection of second element such that AB belongs to R. From all the elements of R, when you make a collection of second element and collection of second element in the range of relation and the collection of first element among all the elements of relation is the domain of the relation. So you remember that. Now question on this. I am taking question. Let set A equals to 1 to 4 and B equals to 1, 4, 16, 25. A relation R is defined as, a relation R is defined as R equals to ordered pair AB such that B equals to A square. Here A belongs to set A and B belongs to set B. Find domain, range, find domain, range and codomain of this relation. That is the question. You have given two sets A and B. I will represent this by arrow diagram, but that is not asked in this question. Your set A and set B is given and your relation R is defined as, I am writing the solution. You must be careful. Your relation R is defined as an ordered pair AB such that B equals to A square. A belongs to set A and B belongs to set B. This is the relation. Your relation is defined in this way. Now you start thinking. Element of B is the square of element of 1. You find the relationship. 1 is a square of 1. 1 is a square of 1. These are the elements of B, these are the elements of A. 1 is the square of 1. It means 1 related to 1. This one is related to 1. This is the first element. Because you have to find out the relation from set A to B. And you have given that B is equals to A square. So 1 is related to 1. Now you take 4. 4 is the square of 2. And 2 belongs to A, 4 belongs to B. So in this way, by this relation, 2 is related to 4. And 16 is the square of 4. So 4 is related to 16. Your relation is square of 16 is square of 4. 4 is square of 2. 1 is square of 1. So in this way, your member of R can be written as 1 1, 2 4 and 4 16. So these are the members of R. Now you need to find out the domain of this relation. From this, now you see ordered pair AB. AB. A is 1, B is 1. A is 2, B is 4. A is 4, B is 6. Or you compare this ordered pair AB with these ordered pairs. You have the element of A. A can assume the value 1 to 4. So your domain of this relation can be written as set 1 to 4. Now come to range of this relation. Your range is the collection of second element B. B assumes the value. B assumes the value 1, 4, 16. Then range of this relation can be written as 1, 4, 16. Now codomain. Codomain is the set B. Codomain is the set B. Codomain is the set B. You remember this. Now pictorial diagram. You can draw the pictorial diagram for this. Arrow diagram for this. Visual representation for this. How can you make that if the question is asked? So first of all, you make set A, then set B. Here 1, 2, 4. 1, 2, 4. And here 1, 4, 16 and 25. 1 is related to 1, 2 is related to 4, 4 is related to 16. That's it. This is the pictorial representation for this relation. Now question. Let set A equal to 4, 5, 7, 9, 11, 12 and B equals to 2, 3, 6, 8, 10, 15 and relation R defined as relation R from A to B is defined as R equals to ordered pair AB such that B equals to A plus 1, A belongs to A, B belongs to B. Find domain, codomain of R. Find domain, range and codomain of R. Find domain, codomain and range of R. That is the question. Now see. So first of all, for all that you have to find your relation in roster form. The form in which your elements are physically presented. After that, you can find domain, codomain and range by their definitions. So now you see, you have given that B equals to A plus 1. B is a member of B. B is member of B. A is member of A. And B equals to A plus 1. This is the relation. When you take 2, when you add 1 to any element of A, can you get 2? No. Similarly for 3. When you reach to 6, when you add 1 and 5, you get 6. If your A is 5, then B is 6. So 5 is related to 6. You find out, you have searched out your element 5 of A is related to 6 under this relation. Now go ahead. Next is 8. When you add 1 to 7, then it will be 8. So 7 is related to 8. If you take A equal to 7, then B is 8. And you can write 7 related to 8. And next is 10. 9 plus 1 is 10. When you take A is 9, then B is 10. So in this way, 9 is related to 10. Now you can write the elements of all the elements of this relation. First element is 5, 6. Second is 7, 8. And third is 9, 10. So what is the domain? Domain is the collection of first element, that is 5, 7, 9, and range is the collection of second element 6, 8, 10, and codomain is the set B. Codomain is equal to set B. Set B is 2, 3, 6, 8, 10, 15. So in this way you are finding domain, codomain and range. Another question. Let set A equals to 3, 5, 10, 15, 20. Set B is equals to 10, 20, 27, 50, 64, 90, 1000, 2000. These are the elements of B. A relation R is defined as, your relation is defined as R equals to ordered pair xy such that y equal to x cube. X belongs to A, y belongs to B. That is the find domain, range and codomain of R. Find, your question is find domain, range and codomain of R. Range and codomain of R. So in this way, first you find your relation in roster form. So you see that when you come to set B, 10 is not, when I am talking about the first element of B, 10 is not the cube of any element of A. 20 is not the cube of any element of B, because that is the relation given. This is the relation we have to search out. 27, now first element is 27. That is the cube of 3. If I take x is equal to 3, our y is 27, and we can write it 3 related to 27. First thing. And next one, when I go to 50, 50 is not the cube of anyone. 64, no. 90, no. 1000 is the cube of 10. When x is 10, then y is 10 cube 1000. So 10 is related to 1000. So when you go to 2000, 2000 is not the cube of any number of the set A, because 20 cube is 8000. 8000 is not there. So 2000 is not the cube of any number of the set A. So member of relation R is written as 327 and 10 1000. In this way, you can find your domain is equals to 310, range equals to 27, 1000, and codomain is the set B. Codomain is equal to set B, and you can write your set B at this place. So in this way, you are finding the domain, codomain, and range of the relation. I hope that you understood this concept with so many examples given by me. Thank you for today. That's all.